In this video, we will not be covering anything new. Isn't that kind of a relief? What I want to do is this video and another one is just go over an example of, in particular, dependent variable, so that you can just see more examples, because that's always helpful. So here's the question. Research conducted by an advertising company determined that 43%, a good idea as you are going through this is, kind of highlight maybe in a different color. Oops. There. Highlight, some of the key pieces of information. 43% of teenagers who saw their product on the display table would go over and pick it up. 82% of those who picked it up ended up buying it. Only 12% of those who did not pick it up would buy it. All right, so this is a pretty real life situation. Studies like this are done actually all the time. There are all kinds of questions that we can ask. What's the probability that a teenager picks it up but does not buy it? Right. Advertisers probably want to know that. What's the probability that the teenager will buy it, regardless of whether they pick it up or not? What's the probability that a teenager picked it up if it is known that they did not buy it? All right, so that's going to be kind of going backwards a little bit. So the first thing we got to do with this is go through kind of our probability checklist. We now have a whole bunch of things that we've gone over. Is this, joint, disjoint, dependent, independent, continuous? Let's just go through the list and try to figure out what best describes what we're dealing with here. So going right back to our probability map, we can go row by row and can say, well, is this discrete or is this continuous? Well, what are we talking about? We're talking about buying a product, picking it up or not. Are those discrete actions or continuous actions? Can you halfway buy something? No, right? So we're talking a discrete variable here. Now we can come down here and say, all right, are we talking dependent or independent? Right? So the next teenager that comes by, are they, assuming they did not see what the first teenager did? There's all kinds of psychology things which are in play sometimes also. But barring that, say one teenager comes in, sees the display, either picks it up or doesn't pick it up, buys it, doesn't buy it, leaves. Next teenager comes in. Is what they do going to depend on what the first teenager did? Especially if they never even saw the first teenager? No, not really. So on one level, you would think that that's starting to talk about independent. But we have to think about what's actually, what the events are. Right? And I kind of went through that because it's a common mistake which gets done. It sounds like, oh, that's a very logical reason. But what's the actual random event that's happening? The random event isn't teenagers coming into the store or not. The random event, right, is picking it up or not picking it up, buying it or not buying it. So the question really is, if we kind of go back and look at this, the question is, does buying it depend on whether they pick it up or not? Well, phrased that way, because we're actually talking about the variables in play here, right? Buying it and picking it up. Are those dependent or independent? That's the real question. And phrasing it that way, I'm hoping that you see that, in fact, it does depend. The chance that they buy it goes up if they pick it up. Or I might be getting ahead of myself a little bit. At least it depends on it. We'll see if it goes up or not when we get into the details. All right, so we're talking about discrete variable. We're talking about a dependent variable because buying it depends on whether they pick it up. All right, are we talking about, again, this is the disjoint versus the joint events. Right? Can you simultaneously buy it and not buy it? No, not really. So we actually are in a disjoint situation, which is very nice, which means we don't have to draw any Venn diagrams. It's only in the joint event that we have to draw Venn diagrams. So what I would suggest is that we actually write this out. It would look something like this. Discrete, dependent, disjoint. So that tells us, what approach we should take. Do we need Venn diagram? No. That's only for joint variables. Are we going to do, binomial or geometric? No, because those are independent variables. So for dependent disjoint, really, in terms of method, we're going to do the tree diagram, which we can start right now. So here we have our starting point. Maybe I'll use a darker color. And what's our first branching? Whether they pick up or not. So you could draw the tree diagram in a couple of different ways. But if we label this as our pickup event, we could either say, yes, they pick up the product, or no, they don't pick up the product. And those are going to have probabilities. Right? What's the probability that they pick it up? Well, 43% of the teenagers who saw their product on the display table would go over and pick it up. So 43% picked it up. So we have 0.43, which means what's the probability of not picking it up? Well, it would be the rest of it, which would be 0.57. All right, next event. Did they buy it? I guess this is a box. And either yes, they bought it, or no, they didn't buy it. Is it always two? It doesn't have to be two branches. We did some examples in which they weren't two branches, I think, before. Pretty typically, they are branches. And so if they didn't buy it, you could either, or if they didn't pick it up, they still could have bought it. Or if they didn't pick it up, maybe they didn't buy it. And there's different probabilities associated with this. Let's look back at the wording of the question. So now down here, so we have 82% of those who picked it up. Right? So this is the yes on the pickup. Would buy it. So yes, they picked it up. 82% buy it. Quick, let's go to the tree. Yes, they picked it up. 82% bought it. Well, if 82% bought it, what percentage didn't buy it who also picked it up? Well, again, it would be the balance. So that would be 18. All right, let's go back. Only 12% of those who did not pick it up. All right, so here's the no on the pickup. 12% would buy it. So didn't pick it up. Here only 12% would buy it, which means of those who didn't pick it up, what percentage didn't buy it? Again, it would be the balance, which would be 88. We can, as we have done with other tree diagrams, get our sample space. So this is the probability of pickup and buy. Oops, wrong buy. This would be pickup and not buy. Why do I keep doing that? Keep doing that. And of course the other ones I can fill in also. Looking like this. I've chosen to use words instead of like yes, 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 no, no, yes, no, no. The words are much more descriptive. The questions are asked in words, and writing these words down will help match up the right part of the tree diagram with the actual question. And so this is an and. So we have, this is our 0.43 multiplication rule times 0.82. And we can run through that, which looks like that, and we can get the probabilities, which look like these. I believe in the video when I first talked about dependent variables, that was the example where we had the drawing a diamond or not drawing a diamond. In that example, I think these two were the same number. Notice that in this example, they're not. That's because when you were drawing a diamond, not drawing a diamond, there was a symmetry because you're talking about a pack of cards. Where here in real life, there isn't a symmetry between these numbers. So we get different probabilities for different outcomes. Now we can go back and start looking at some of these questions. Let's look at the first one. What is the probability that a teenager picks it up but does not buy it? So, writing that out in probability format, looks like this. Probability picks up but not buys and not buys. Now you can see it's really easy. This is one of our choices here. And so you just pick it right off of the tree diagram. 7 3/4, 7.8% chance of picking it up but not buying it. Let's look at the second question. What's the probability that a teenager will buy it? Now again, the wording of the questions is crucial. It's just asking about buying it, regardless of whether they picked it up or not. So if we were to write this in probability form, it looks like this. The probability of buying it is the probability of picking it up and buying it, or the probability of not picking it up and buying it. Either situation, they buy it, which is what we're interested in. And so now it's hopefully a little bit more clear. It's an or. So, addition rule. And it turns out to be about 42% chance of buying their product, whether they pick it up or not. Let's look at question number 3. Or before we do that, maybe a few things I want to say about this before we move on. Notice what we're adding. Over here, right, this is our sample space. A common mistake is to say, well, we're looking for where we buy, or where the students buy, or teenagers buy. So here's the yes buy, here's the yes buy. Shouldn't we add those up? And you'd get 94%, which is inaccurate. You don't add these up because you're not asked for the second event probability. You're actually asked for both first and second combined. So we add up these two. Another way of thinking of it is these percentages just tell you the breakup of this, right? So of this 43%, 82% go up here and 18% go down here. Right? So we actually want to know, well, what is that 82% of this group? Well, that's this number. And this is telling you, well, 12% of this group bought it. Well, what is 12% of that? Well, that's this number. Right, so those are the numbers that we really want to add together. Now, if we were asked what's the probability of buying it if they didn't pick it up, then that's actually asking for this number. It's asking the probability for the second event, which is whether they buy it or not. But with this, they were asking, essentially for the third column. All right, so now, third question. What's the probability that a teenager picked it up if it is known that they did not buy it? I hope you don't mind I shrunk things down a little bit. I think I'm going to need a little bit more room for this because this is, like I said before, the backwards working one. All right, so we're asked about the first event given information about the second event. All right, so they didn't buy it, so here, this group and this group, really this group and this group, right? And of this whole group, right, how many, what do we ask for, picked it up, which means, this. Right? Remember when we went over this in the original video, we went right back to our frequency ratio, which looks something like this, which we can put these numbers in for, which looks like this. And then I'll show you, I didn't write it in probability format. I'll give you the answer in that format. So the probability that they picked it up, given that they didn't buy it, is about 13.4%. Another notation for this, which you'll sometimes see, I can show you, looks like this. Just this vertical line is kind of the given. It's, I guess, a little bit more concise, but that's really the only difference.